I've been working on bipedal robots for the past 10 years. Our focus has been on developing walking and running gaits from scratch using mathematical principles and have them work well on the robot. This is Mabel. So Mabel has 1 degree of freedom hips. The robot is designed to have these very large springs. Its legs act like pogo sticks when it runs. These are made out of fiberglass. It's the same material you use for making archery bows. Complicated cable connection. That's actually creating a set of differentials. These differentials create a motor in series with a spring connected to that leg so that it bounces up and down like a pogo stick. This is what gives Mabel the ability to step off these very large obstacles and simply absorb them as a shock absorber would in a car. Or it gives it the ability to run with a lilting gait that's very similar to how a human runs. We are sending commands for it to speed up and slow down, but that's about it. The role of the bar is providing side-to-side stability of the robot. It is not holding it up. The robot is under independent control here. The fastest walking gait we've achieved is 1.5 meters per second, which held the bipedal speed record for about 4 months. The fastest running speed we've achieved is 3 meters per second, so that's a 9-minute mile. That also set a record. Another record we have, which is dealing with the robustness of our walking gaits. We have robots that can walk blindly. What we envision is the robot being used in a rescue and disaster situation. There's going to be lots of debris, dust, lighting is going to be poor. So even if you have a camera, it's not going to give you very accurate ground height information. So you need a robot that can hit objects without tripping and falling. So you see Mabel is here walking around on a ramp which suddenly comes to an end. The robot has no idea that it's actually walking up a ramp. So the key thing is when the robot steps off the platform, it can in a millisecond determine the height of the platform. When you go from a height to a lower height, you've changed potential energy into kinetic energy, and you must dissipate all of that, otherwise your robot will slip and fall. That was a 16.5 to 18 centimeter height there, 7 inches. Now it's going for 8 inches, which is 20 centimeters. I think most of us would have broken an ankle at that point. Mabel's feet here. It's really easy to compare the gait that Mabel is executing versus the gait that of a normal human walking. And then you should be asking yourself, which one is better, in all honesty? There goes Mabel. And there goes Ross from the Discovery Channel holding the camera. You decide. Atrias on the far right is a new robot we are building. It'll be a full 3D walker, meaning that it will be able to walk completely independently. It'll be battery-powered, wireless interface, and you should expect to see it out on the Lurie Mall in the upcoming year.